welcome to the next video. Here we are going to see in detail about HELL-VOLHARD-ZELINSKY reaction. So it is nothing but alpha halogenation into carboxylic acids. The carboxylic acids which is having alpha carbon, and in that alpha carbon hydrogens are present, means that hydrogen can be replaced by halogen. So alpha halogenation was discovered by three scientists, Hell, Volhard and Zelinsky. So hence this alpha halogenation reaction on carboxylic acid can be called as Hell-Volhard-Zelinsky reaction. When a carboxylic acid containing alpha hydrogens is treated with halogen in presence of red phosphorus, the alpha hydrogen atoms are replaced by halogen atoms. The reaction is known as Hell-Volhard-Zelinsky reaction, has a wide synthetic utility. After bromination, we can replace the bromine with some other functional group, some other reagent, and we can convert it to some other functional group. Thus, acids are convenient starting metals for preparing the alpha substituted acids. So here, what is the reaction? So the carboxylic acid, which is having alpha carbon, and in the alpha carbon two hydrogens are there here. It is treated with bromine. Here halogen, bromine is the halogen here in this case. In presence of red phosphorus, the bromine is substituted to the alpha position of the carbon with the hydrogen. So instead of hydrogen, one bromine is replacing the hydrogen in the alpha position. So hence it forms alpha bromo carboxylic acids. So after converting the hydrogen into bromine, that bromine can be replaced with so many other groups to form various substituted carboxylic acids. So in the first case, the alpha bromine is reacting with the sodium hydroxide, and NaBr is released, and the OH is attached at the alpha position. So hence it forms alpha hydroxy carboxylic acids. In the second case, alpha bromo carboxylic acid is treated with sodium cyanide, and it forms, with the liberation of sodium bromide, it forms alpha cyanocarboxylic acid. And in the third case, the alpha bromo carboxylic acid is treated with ammonia. And the third case, the alpha bromo carboxylic acid is treated with ammonia, and HBr liberated with the formation of alpha amino carboxylic acid. So this hydroxy carboxylic acid, cyanocarboxylic acid, amino carboxylic acid are further we can able to get from the alpha bromo carboxylic acid. Hence this Hell-Volhard-Zelinsky reaction is an important reaction for preparing various substituted carboxylic acids. So this particular Hell-Volhard-Zelinsky reaction is nothing but alpha halogenation, in particular alpha bromination in our case. So during the alpha bromination in presence of phosphorus, the bromine atom attached to the, replacing the hydrogen atom available in the alpha bromo position. Let us see the mechanism of the reaction. In the first reaction, the phosphorus and the bromine will react, and it forms PBr5, phosphorus pentabromide. The two equivalents of phosphorus, while reacting with the 5 equivalents of bromine gas, it forms phosphorus pentabromide. This is the first step. And in the second step, the formed phosphorus pentabromide reacts with carboxylic acids and form acid bromide. It is similar to acid halide reaction which we have seen in the previous video. When carboxylic acid on treatment with phosphorus pentabromide, it forms acid bromide. So acid halide, in this case acid bromide, that is RCH2COBr, with the liberation of phosphorus oxybromide and hydrobromide HBr. This is the step 2. And in the step 3, the third step, first case, the keto form converted into enol form. The keto form converted into a enol form. So here RCH2COBr, acid bromide, will go interchange into a enol form. Here tautomerism is possible. Keto-enol tautomerism happens in this case. The RCH2COBr converted into RCH double bond COH-Br. From the keto form, one hydrogen is replaced from the alpha carbon, and the electrons shifted towards the carbonyl carbon and makes a double bond, and the double bond between the carbonyl C and O bond is pulled towards itself by the oxygen, withdraw the electron and makes oxygen negative, and the hydrogen which is released from the alpha carbon as H plus will go and attaches to the carbonyl carbon, carbonyl oxygen, and forms as a OH group. In the first case it is keto form, in the second case it is enol form, one alkene and along with one alcohol. So enol form is formed. After the enolization, the bromine gas is attached with the enol formed alkene carbons. So the alkene carbon, the second double bond break, and two bromine atoms attaches with the two carbon atoms on the two sides of the double bond. So the double bond between the carbon-carbon is broken by the bromine gas, and two bromine atoms attached to the two carbon atoms. So this is the next step. And after that, the oxygen lone pair available on the oxygen will be dragged towards the carbonyl carbon and forms a C double bond O. So because of the donation, the oxygen is getting a positive charge because it loses a pair of electron to make a double bond, and the bromine liberates as a Br minus, as a bromide ion. So the next step, the bromide along with the bromide ion, in order to balance the charge, the hydrogen which is at the OH group, the OH group hydrogen, the OH bonded electrons will comes all withdrawn by the oxygen atom and satisfies the positive charge which is raised in the oxygen atom and balances the charge. Then thus the hydrogen will go as a H plus atom. The H plus and Br minus will releases as HBr. Hence the formation of alpha bromo acid bromide. Already one bromine is there in the acid bromide. Along with the bromide, one bromo at the alpha carbon is created now. So hence in the third step, at the end of the third step, we are having acid bromide along with alpha bromo. Alpha bromo acid bromide we are getting in the third step. And the fourth step, step 4, in the step 4, the alpha bromo acid bromide is reacting with the next molecule of acid, carboxylic acid, and the interchange or replacement of bromine and OH group happens in this case. The bromine from the acid bromide replaces from this replaces from the alpha bromo carboxylic acid and goes and attached to the carboxylic acid by replacing the COH group, replacing the OH at the COH group. The OH which is replaced from the carboxylic acid and comes and replaces the bromide atom which is in the alpha bromo carboxylic acids acid bromide and forms a carboxylic acid. That is, in the first here two molecules are there. One is alpha bromo acid bromide, another one is carboxylic acid COH. From the carboxylic acid, the OH groups comes and replacing the bromide atom in the acid bromide, and this bromine atom from the acid bromide releases and goes and attaches with the carboxylic acid as acid bromide. Hence RCHBr COOH acid bromide along with carboxylic acids alpha bromo carboxylic acid, two products formed. So the first product, which is nothing but alpha bromo carboxylic acid, is our target product. Along with the target product, it also forms acid bromide from the alpha carbon which is having hydrogen. So this acid bromide again taken place for the enolization step. The formed acid bromide enolized to form a enol form, and to the enol form again bromination is happening. Again bromide ion and along with the H plus atom is releases as HBr and form the acid bromide. This acid bromide again step 4. So reacting with the second molecule of carboxylic acid and forms alpha bromocarboxylic acid along with one acid bromide. This acid bromide will go and react with by ionization along with the bromine gas and forms the alpha bromo acid bromide, and this acid bromide reacting with the third molecule of carboxylic acid. So in the same way, all the molecules are replaced one by one. The first step, the bromine attaches in the first step, the bromine reacts with the phosphorus and forms phosphorus pentabromide. So it is happening one time only. So the formed phosphorus pentabromide, here we are adding so much of bromine. So in the formed phosphorus pentabromide reacting with the carboxylic acid and forms acid bromide. So this acid bromide is initiated the reaction. The acid bromide, next step ionization. After ionization, bromine gas attachment, and after bromination, liberation of HBr and forming alpha bromo acid bromide. This alpha bromo acid bromide are reacting with the next molecule of carboxylic acid and forms alpha bromo carboxylic acid along with the acid bromide. So continuously the forming acid bromide will undergo the step 3 and step 4. Step 3 and step 4 continuously will happen. From the step 4, the formed acid bromide undergo enolization as per the step 3 state and converted into enol, and in the enol bromination is happening. Bromination attaches breaking the double bond and attaches to bromine atom on the two sides. So along after that HBr liberation will be there. After the HBr liberation, so alpha bromo acid bromide is formed. When it reacting with the next molecule of carboxylic acid, the OH and the bromine replacement is happening, and hence acid bromide alpha bromo carboxylic acid is formed. So in the same way, repeatedly this reaction happening. So in the first step, phosphorus and bromine react with the phosphorus pentabromide, and the second step, carboxylic acid and reacting with the formed phosphorus pentabromide and forms acid bromide in the second step along with the liberation of PO, Br3 and HBr, and the formed acid bromide in the second step is reacting undergo ionization in the third step, undergo ionization. After enol form, it reacting with the bromine, and the bromine cleaves the two double bond and attaches two bromine atom on the two carbon atoms. With the liberation of HBr, we can form alpha bromo acid bromide, and in the fourth step, the formed alpha bromo acid bromide reacting with the carboxylic acid, and the carboxylic acid, it is containing alpha bromo carboxylic acid is the target product along with the formation of acid bromide. The acid bromide which is formed in the fourth step is reacting similar to the acid bromide in the second step during the third step. So the formed acid bromide undergo ionization, and the enol again bromine attachment is there. The bromine breaks the double bond and attaches two bromine atoms, and followed by a liberation of H plus and Br minus as HBr, there produces alpha bromo acid bromide. So this alpha bromo acid bromide in the fourth step, so it will react with the carboxylic acid, and the substitution of bromine and OH between the two molecules happening, and the bromine and OH replaces between the two molecule, and COH COBr interchanges as COOH and COBr. So this kind of transition is happening between the two atoms, and at the end of fourth step, the alpha bromo carboxylic acid formed along with alpha hydrogen only there. Alpha hydrogen acid bromide is there. This acid bromide again undergo enolization, which is in the third step, and after enolization, bromine addition, HBr liberation, and fourth step, it is substituting with the OH group. So likewise, continuously, all the molecules of carboxylic acid converted into alpha bromo carboxylic acid. Hence, the HELL-VOLHARD-ZELINSKY reaction, which is nothing but when the carboxylic acid on reacting with bromine in presence of red phosphorus, so alpha bromo carboxylic acid is formed. Thank you.
இந்த வீடியோ உங்களுக்கு பிடிச்சதுன்னா லைக் பண்ணுங்க, ஷேர் பண்ணுங்க, கமெண்ட் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணுங்க. மறக்காம பக்கத்துல இருக்க பெல் ஐகானை கிளிக் பண்ணுங்க.